So my name is Ali Bakhtiyari. I'm a third year PhD student here at the iSchool University, Syracuse University. And my main research interest is in how AI is transforming organizations. But over the past year, I've been focusing more on the open source community and virtual organizations. And today I'm going to share a research that I've been working on with our collaborators, Dr. Sean Goggins from University of Missouri and my supervisor, Dr. Joshua Introne. And it's titled The Impact of AI-Assisted Code Review Tools on Open Source Software Contributor Dynamics. So we know that AI is affecting work, especially cognitive work. And we know that it's affecting computer programming because large language models can generate code and they understand code. They can give feedback on code. Now, um, I wanted to understand and see when AI is incorporated in a system like the open source software within the repositories, like what are the effects? What's changing? Like how's the community adapting? Like the code is changing, the routines are changing, the ways of things, the processes are all changing, and the behavior of contributors as a result are changing. So with this study, I'm focusing on pull requests specifically because in pull-based repositories or projects, uh, pull request is the main artifact where when AI is uh, incorporated in the process of the review, we should see effects that are visible through the data that's openly available through pull request conversations. And this study is primarily quantitative. We are using data from the Augur database. And this is like a study at scale. We're looking at millions of pull requests. So I'm going to give you a quick glance of this study. I have my research questions here. So the literature has like a wide range of studies on open source communities and AI already, but most of them are focusing on the technical aspects like hallucinations, productivity boost, comparison between models. But with this study, I'm trying to focus more on the socio-technical aspect and the human subject. So with my first research question, I'm asking if a repository is using or starting to adopt um, large language models in the review process, do people join more, or does the rate of joining changes at all? And just to give you a quick uh, finding, like the findings shows us that it doesn't. Like joining rates don't get affected by AI reviews. With my second question, I'm asking if the rate of churn is getting affected by AI being used in the review process. And my findings show that AI reviews dramatically accelerate churn, especially among experts. Uh, they're much more effective. They leave projects much more often after AI is adopted in a project. And with my third research question, I'm asking about activity patterns of developers. Like I want to see if the count of commits change, like if commit behavior is changing, if pull request submission rates are changing, and if the communication is getting affected. And I'm looking at this uh, stratified by experience. Uh, this is an this is an overview of my method. So I wanted to see the effect of AI in repositories, and in order to study the effect of AI first, we needed to see where AI is. We need to pinpoint places where people are actually using AI or talking about AI. And since this is not something that is declared in projects, some projects have policies that require contributors to actually say that they are using generative AI in their contribution. But For this study, we are relying on semantic signals. So we are looking at the pull request conversations, and we are trying to see if we can find usage of AI, the evidence of of AI through the conversations in pull request, which I will talk more about in a second. And to do that, uh, we developed a classifier to to classify our pull requests into AI related and not AI related. And to train a classifier, first we needed a set of labeled data set. Um, and we didn't have that labeled data set, like a data set of pull requests being categorized into AI and not, so that we could use it to train a classifier and have it learn the patterns. So we created that golden data set by doing a quick keyword search, looking for like keywords such as Gemini, ChatGPT, Claude, and a lot of other keywords. But the problem with that was that would return a lot of false positives. For example, if you looked for cheap GPT or Copilot, it could be returned in the result, but in another context. For example, GPT being another acronym for something else, or Copilot being something else other than what we are looking for, which is the generative AI programming tool. So we had like an LLM help us create this data set where we crafted a prompt, and in that prompt we provided clear definitions of each of the categories that we wanted. We have 5 AI categories that I'll show you in a second. And then through refinement, we categorized 10 pull requests into uh, AI related and not AI related. Um, And then we use that classifier to infer our entire corpus of 8.5 million pull requests. And once we did that, we had the data that had evidence of AI. Like we knew where AI was in pull requests, which repositories were using it, uh, and uh, we could actually answer the research questions that I had. So we had a few criteria to filter, like a subset of repositories that we wanted to study. So my focus again is on pull requests and use the usage of large language models in the review process. So I primarily filtered for that. I looked for pull requests that had at least 20% of their pull requests being reviewed by AI. They had more than pull requests, so uh, it was an active um, repository, and we wanted to have like a baseline to compare against. So we looked at repositories that at least had 6 months of history prior to the adoption of AI. And then I developed statistical models on top of this data to answer my questions. I use survival analysis models and mixed effect regressions. So these the figure on the right shows the training plots of my classifier. I I mean I don't want to get too much into technical details of the training process, but um, we got 90% accuracy after optimizing for our configurations like the hyperparameter tuning and 78% F1 macro. And this was the model we used once we had this classifier. We used this classifier to infer our entire corpus of pull requests. And since this was a very resource intensive task, we conducted this massive inference on on SU's orange grid, which is a grid of GPUs available at one point, I had like 90 GPUs inferring my data. So this was like a very resource intensive task and took about 2 days. Uh, I have here my categories of uh, AI that I had the LLM find and I do my studies on. I'd like to do like a quick definition of what each of these are. The first category is direct generative AI usage, which is the developers talking about the use of like the actual usage of AI to generate some artifact, like someone saying, I used ChatGPT to generate this code snippet. Uh, and the second category is AI-assisted PR work, which is the focus of this study. So this is different than uh, the first one. We wanted to see if whenever a bot was called or an LLM was used anywhere in the review process and we could see it in the pull request, we wanted to flag that. Like if someone was calling bots for automated reviews and revisions, or if someone was using an LLM for summarizing um, the pull request, we wanted to see that. And the third one, the third category is traditional machine learning development. Again, this is AI also, but it's a different kind of AI than what the focus of this study is. We wanted to also find this to allow us for comparison. The fourth category is LLM app development. We wanted to find pull requests that used large language models or AI, but they weren't using it for generating program. They weren't uh, talking to a chat bot asking it to generate code for them. They were using the large language model like in the heart of their project or somewhere in their project, such as an example of that would be using large language models for a chatbot or like a project that could incorporate LLM uh, into their project in some way. And again, this is different than the rest. And the distinction is very important for us to know. And the fifth category is AI discussion, which is talking about AI policy or anything else that didn't fit really in the rest of these uh, AI categories that we have here. And number six, the category six is unrelated. So the pull requests that had nothing to do with AI, no mentions of it, we couldn't see any evidence of AI usage in them. So once we inferred all of these six categories on our 8.5 million pull requests, we aggregated uh, our findings, our results, and we put it on a line graph here. If you look at the top line graph, you can see this gray line is unrelated. You can see that the majority of pull requests were unrelated because not everything in the open source software is about AI or um, and you can see that only a small percentage of AI categories are down here. If we zoom, the figure at the bottom is you're actually zooming in this section. And this is the uh, launch of ChatGPT in late 2022. And we can see that the trend's really picking up after this line, after the launch of ChatGPT and LLM becoming more capable and popular. Uh, Specifically, this blue line that shows AI-assisted pull request work that we can see it's increasingly growing, especially you can see a big shift here in 2025. So from 2022 to 2025, we see a 600% increase in the use of AI-assisted in the use of bots in the pull request review because bots were used in the pull request even prior to large language model becoming so popular, but uh, their usage was limited. Now, getting back to my research questions and my findings that so for my first research question, which is about the rate of joining, I didn't find any significant effect of AI on joining rates. But however, I did find that if as a project gets bigger, the rate of joining increases. And I also found that repositories' age has an effect on recruitment or joining, meaning mature repos attract fewer newcomers. And the main takeaway from this question is that AI adoption does not repel or attract new contributors. We didn't say an effect, at least not that we could see in this data. For my second research question, I was asking about the rate of churn. I wanted to see if people were leaving projects because the project had adopted AI heavily in the review process, and we found that yes, people are leaving more often, especially experts. The rate of churn for experts is about 300% more compared uh, to the time prior to the adoption of AI, but intermediates and novices are also churning. And this is consistent with the literature because we can see in the literature that experts dissatisfaction with uh, uh, their 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 pull requests being reviewed by AI, and they often ignore AI reviews. And the takeaway from this one being that all experience levels get affected by AI, people in terms of churn, but experts get affected the most and they leave the most. And for my third research question, I was asking about activity patterns, specifically communication, commits, and peer submissions. And we're looking at it, I was looking at it stratified by experience. And we found that communication intensity has decreased. We can see a decline in there, especially among novice contributors. And this is in line with the findings of the literature, because one reason for that could be people are talking less to each other. If a novice contributor has a question, they would just ask ChatGPT instead of asking um, an expert contributor and waiting for a response. If the contributor might be too busy to even respond in the first place. And we also see in the literature that contributors have a preference for AI generated uh, responses to programming questions because AI provides uh, a very polished, fluent, and to the point answer to the questions. But the problem with that is sometimes that uh, assertive and convincing language could include hallucinations in it. For my pure submission rates, uh, I found that novices are submitting more pull requests, unsurprisingly, because anyone can write code with a prompt. You don't need to be an expert necessarily to solve a problem in terms of writing code. But experts are writing much less code, which could be attributed, again, we cannot see from this data, but this could be attributed to the fact that experts are changing their roles more to uh, validating and maintaining code rather than generating code because uh, it used to be generating code, it used to be the main work of the experts submitting pull requests. But now they're switching more into validating because not everyone can validate. Only the expert looking from uh, top down can see the problems with AI generated code. And in terms of commit activity, we did not find any significant changes at the adoption. And thank you very much for your attention.